we're now going to divide complex numbers. And again, just like when we did this with radicals as a whole, because remember, complex number is just involving a specific radical, namely the square root of -1, what we're really doing is rationalizing. We don't want any i's in the denominator. And so let's look at our first example. Suppose we have 2 minus I over 4 plus 3i, and we want to get rid of that radical. We do not like that radical. So what we want to do is we want to find its complex conjugate. So we look at the bottom, and we copy the numbers, and we change the sign, so it becomes a minus sign instead of a plus sign. Then we're going to practice our FOILing. 2 times 4 is 8 minus 6i. And I'm going to do something a little bit different. When I do this one, minus 4 times I, I'm going to write it directly underneath the minus 6i from before. And then a minus times a minus is a plus, 3i squared. And then I'm going to get rid of the i squared and turn it into a minus 3, so that my real part's on top and my imaginary part is second. They line up. Because then all I have to do is add. So this is 8 minus 3 is 5 minus 10i. So here is my numerator. Notice we're not done yet, so don't stop. But now we get to do our denominator, and because it's a complex conjugate, we know that this is a difference of squares. And so it's really going to be 4 squared, the first, plus, since the I is going to change the sign, 3 squared. Or we can look at this as 4 squared minus 3i squared, and remember that the I squared then is going to change the sign. So this becomes 16 plus 9, which is 25. So here's my denominator. We then write this out as 5 minus 10i over 25, and this is what I was referring to earlier. We don't like this as an answer, so we're really going to write as 5 over 25 minus 10 over 25i. Notice the I is on the side. We then reduce our fractions separately. It becomes 1/5 minus 2/5 I, and we get our answer. So just to make sure I show this enough, I'm going to do one more example. Suppose that we have 4 plus 3i over 1 minus 3i. And I'm going to do one more example before we talk about the single term. And so again, we want to recognize our complex conjugate. So we're going to take our numerator, and we're just going to take whatever's there, and we're going to change the sign between them. So instead of being a minus, it's going to be a plus. So now we FOIL. 4 times 1 is 4. 4 times 3i is 12i. 3i times 1 is 3i. And 3i times 3i is 9i squared, which I'm going to change into a negative 9 to deal with the I squared. 4 minus 9 is minus 5. 12i plus 3i is 15i. In my denominator, I'm going to take the 1 squared, and I'm going to add 3 squared, because remember the I squared turns that into a plus instead of a minus. So this becomes 1 plus 9, which is 10. We then break this up as minus 5 over 10 plus 15 over 10i. Reduce our fractions to get minus 1/2 plus 3/2 I. And here is our simplified answer with no i's in the denominator. Now the last example I want to show, just to make sure we're clear about this, if we have 6 plus 5i over 3i, remember this is really a 0 plus 3i. So what we want to multiply on top and bottom is 0 minus 3i, which is just better written as 6 plus 5i over 3i times minus 3i over minus 3i. We don't need that 0, because when we multiply anything by 0, it goes away. So now we just FOIL this, distribute this through, we get minus 18i minus 15i squared all over minus 9i squared. Well, remember the I squareds turn into minus 1, so that changes. So we really have 15 over 9 minus 18 over 9i. Simplify our fractions, we can pull a 3 out. Leaves us with 5/3 minus 2i, and there is our answer. And that's how we rationalize complex numbers, or how we divide complex numbers.